Okay, and welcome back, students who are taking Math for Business and Finance and Math Applications. And we're continuing on with the Chapter 10 drill problems, the assigned odd number problems from the study guide. And we had stopped on problem 5, 10-5. So let's pick up with 10-7 and 10-9. Now, for doing this problem, I actually started doing these, started doing a video, and I stopped because I decided to add a Julian calendar, right? The exact number of exact days in a year calendar. As you can see, it's table 10-7-1. So it was in chapter 7 that you saw that particular calendar. And I inserted this slide, so we'll use this slide for some of these instead of drawing a number line, a timeline, I'm sorry, and doing it that way. You saw me do that in the previous video, and both ways work. It's just a matter of which one you find more efficient, and I decided that to save, in interest of saving time, I added that particular slide with the calendar in, and now you know what table to go look at in order to be able to calculate the number of days. Okay. Now the other thing is, remember from problems 10-1 and 10-3, that was based upon a month. Now 10-5, it had said to use the ordinary interest. Well, 10-7 and 10-9 is talking about exact interest. And remember, the exact interest is 365 days in a year versus ordinary, which was 360 days in a year. But notice that's per year, okay? And this 365 days was per year. The thing about getting into the simple interest, compound interest, and the in later chapters, I mean, compound interest is going to be covered in chapter 12, and the time value of money is another concept you'll be learning in a future chapter. But the reason why I'm bringing it up is because of what I call time frames. All right. When we're talking about, say, I mean, we're doing here simple interest, where we're borrowing $1,000 at 8% or 0.08, all right, for a period of time. But this 8% interest here is an annual interest rate, a yearly interest rate. Okay. When we get into the time value of money, or even compounding in future chapters, and I'm just going to give an example of what I'm talking about. Let's say you borrow $100,000, okay, and you're borrowing it for 30 years at 12% a year, but you don't know how much the monthly payment is. Okay. Well, this is yearly, but this is monthly. You can't calculate the problem. I mean, you could, but it's a lot more complicated than it needs to be. What you should do is you should convert the years into the number of months. So there's 360 months in 30 years, and a monthly interest rate is 1%. So now that I have this in months, and I want to know what my monthly payment is, the time frame, okay, is all the same, and it makes doing the problem so much easier. Well, we're doing the exact same thing here, okay? We're looking here and we're saying, okay, these are annual interest rates, but when we're using exact interest, that's a yearly calculation, right? 365 days, or ordinary is 360. So we're keeping everything within the same time frame. We're keeping the annual interest rate in an annual time frame, all right? A yearly interest rate in a yearly time frame. So for this problem, for problem 10-7, we're keeping everything in the same time frame. Using the exact interest, in the denominator goes 365 days. Now all we need to do is figure out how many days that we're borrowing the money for and put that in the numerator. And so we're looking at March 8th and June 9th. So like I said, you can draw out a timeline and label this, March 8th, and this is June 9th, and then hash mark it off, write in the days, calculate, know how many days and then add them all up, or you can use the exact number of days in a year calendar, okay? And for this, we were looking at March 8th, so this is, oh, that's May, sorry. Here's March, okay? And it was 8, so that's 67 days. March 8th is the 67th day. And for June 9th, so here's June, and here's the 9th, that ends up being 160. So I take 160 and I subtract 67, and I end up with 93 as the exact number of days, okay? So when you're going across multiple months, I find using that calendar, the Julian calendar, easier than using a timeline. However, I'm not opposed to using a timeline, especially if I don't have the calendar handy, and or it's a very, very short time frame and I can almost mentally do it in my head. So we had determined that the number of days was 93. Yep, 93. So the exact time there is 93. And as you can see, this is just a repetitive task, right? I mean, it's the same exact steps that we did in problems 10.1, 3, and 5, okay? I'm going to multiply across the top, 1,000 times 0.08 times 93, and I end up with 7,440, and that's divided by 365 days for the year, okay? And that gives me $20.38 as interest. And of course, the maturity value is interest plus principal, so the interest is $20.38 plus the principal of 1,000, gives me $1,020.38 for the maturity value. Right? Like I said, very simple, very repetitive. Right? If you've done the others, you're probably getting accustomed to this now. Okay. All right. Problem 10.9, $1,200 in interest times 0.12 is a 12% interest rate in decimal form, times, okay, exact interest is 365 in the denominator, and we have to look at July 7th through January 10th. Right? Now, let's go down to our calendar. So we have July 7th through January 10th. So July is here, and the 7th is here, which is 188. It's the 188th day. Now, we know there's 365 days in a year to get to December 31st. So 365 minus 188 gives me 8 from 5 is 7, 177 days. And then we have an additional 10 days, right, from January 1st to January 10th. So I have 187 days for that time frame. Okay. All right. So, and again, we're wrapping around the calendar here. We started out with this day here at 188, and we went to the end of the calendar. Well, the end of that calendar, for the next year begins right here. So I went from 1 all the way down to day 10 in, the month of January. Okay, so that's where I get that 10 days from. 300 from here to here is 365 minus 188, or 177 days. But to go from here to here, from January 1st to January 10th, is 10 days. And I add those two together, all right, to get the 187. All right. Erase all of that and plug that into the problem. So 187. So I put the 187 in the numerator, and then it's just a matter of doing the math. 1200 times 0.12 times 187 gives me 26,928. over 365. And then so I just divide that by 365 and I end up with $73.78. Now I'm rounding to the nearest cent. It was actually 73.775342 in my calculator. But since I'm only dealing with dollars and cents, I'm rounding to the next cent. So if I'm here at a penny, I look right. 5 and above means I round up, and that's why I rounded to $73.78. So that's $73.78. The number of days here is 187. And for the maturity value, it's the principal, which is $1,200, plus the interest of $73.78. And that gives me $1,273.78. Okay. Okay, so let's see here. I've got 2 more problems to go. And problem 13 is going to be a lot more complicated, so I'm going to stop here and pick up in the next video.